Good morning, and welcome to our webinar on wood construction insights and experiences from Austria. My name is Cosima Steiner. I'm the commercial councillor, the Austrian commercial councillor here in Denmark, and representing Advantage Austria. We are Austria's internationalization and innovation agency, and Advantage Austria Copenhagen is the Copenhagen office of Advantage Austria. We connect Austrian and Danish businesses so as to exchange ideas and to learn from each other and to work together. And I'm very happy you can all join us for our webinar today. I will, in a few seconds, introduce our cooperation partner here, Michael Koch, the director of Tra Information. He's currently not in the picture because usually we'll be standing closer to each other, but we're trying to keep our corona distance. So I do apologize already that there will be a little bit of more back and forth today, and maybe sometimes you also hear me yelling from the sidelines, even though I'm not in the picture. But these are the times, and I do hope for your understanding. Let's have a quick look at the agenda. Well, welcome introduction, we're right in the midst of it, and as I said, Michael come in a couple of minutes and also tell you a little bit about the status of wood construction in Denmark. And afterwards, in about 2.5 hours, we'll have 4 presentations by 4 experts on different topics we've identified as of interest for a Danish audience. Each of them will speak for about 20 minutes, and then we'll move into question and answers, which each and every one of them. And then in the very end, there will be another Q&A session in a big round with all the speakers, and all of the Q&As will be moderated by Michael Koch. Finally, a few words from me still. Why are we doing this? Why is Advantage Austria Copenhagen organizing a webinar on wood construction? Well, wood is an attractive building material. It's a very trendy material. It's a sustainable and very innovative material. And it has seen increased popularity over the recent past internationally, but also in Denmark. And Austria and its companies, we have a very long tradition in wood construction, and some of the world's top manufacturers and producers come from Austria. So this webinar is one event in a series of events. We've been already organizing webinars, seminars, and fact-finding tours for architects, engineers, contractors to Austria, oftentimes cooperating with Tra Information with Michael Koch. So if you think this is an attractive proposition, then please stay in touch with us because we're currently planning more events to come, especially our next fact-finding tour to Austria, which will be in 2021, keeping our fingers crossed. But that's from my side from now, and I will now ask Michael Koch to come in and say a few words of introduction as well.
Good morning, everybody. We are lucky that we got this opportunity to work together with Advantage Austria in presenting some issues during this corona crisis. We'll come back to you with normal courses after the summer. And we have tried to put together a program that could be of Danish interest and to get to know some of the expertise that we have in Austria. We try to get expertise from wherever we can get it and present the useful facts for you. We'll go through, we have had some questions from our members on different items. Some of them will be covered today. So one of them is, are there any companies that can do turnkey delivery? Because we, especially in Greenland, it's a big opportunity. And some of you might reflect on that. We also have a proposal on how to combine concrete with wood. We are not, in that sense, religious on just focusing wood. We should combine materials for whatever they are best to. So that will be nice to get an insight with that. And then we also have more complex buildings. I think it's an eye-opener for you to see that quite a lot of possibilities can be realized in wood by combining wood in different matters with different techniques and so on. And some of the more complex buildings we have seen in Austria are quite spectacular, and we can learn from them. And in the end, we will also be looking into surfaces. It's very it has been of big interest for Danish architects to have exposed wood in the surface. We have some fire demands that doesn't make it that easy, but it's possible. But also we have to look on the climate change we have here, where we have humid summers, very dry winters, and how does the surface react and so on. And we have some answers to that where you can specify more specific surfaces. So I look very much forward to these presentations, and I'll give back the stage to Cosima.
Yes, thank you very much, Mckellen. And yeah, moving on to our first presenter, Per Thomas Dahl. He is the CEO of CLT Denmark. CLT Denmark is a partner of Austrian company KLH from Styria that has actually pioneered CLT in the 90s and has then moved on to being an internationally very successful company with projects all over the world, if I'm not mistaken, also already in Denmark, first activities. So yeah, Per Thomas, welcome, and we look forward to your presentation on how to get a project realized with CLT.
Well, thank you very much, and thank you for the opportunity to get to the seminar and speak here. I could have done it in Danish, but now it's in English, and that's fine for me. So I have a brief presentation here regarding what we're doing, how we can make projects, and so on. And I have divided the presentation in 3 sections. First, about the idea and why we should build with CLT and wood. Something about the processes and the decisions we are going through when we are working with CLT. And finally, about execution and production, what is going on there. As Cosima said, we are working together with KLH from Austria, having more than 30,000 reference projects throughout the world. And I will also come back to that, where you can see some nice buildings. Anyway, let's go to the idea and why we should work with CLT and wood. And of course, the no-brainer is sustainability. We know that the carbon dioxide factor is important to work with, and we know that the CO2 is stored into the wood. We use less, or we give less CO2 to the environment when we are working with CLT or wood in total. So the account of CO2 is very easy to calculate. You can always discuss whether the stored or embodied CO2 is actually released again later and to what purpose. But in the end of the day, it is a very positive calculation. Further than that, GNB is also scoring other factors, which is related to the use of wood, because it's a light material. It's easy to work with. It's giving less waste and so on. And finally, also the disassembly, the flexibility of the product, and so on. So in total, when you look at sustainability, you should actually look more into the factor other than only CO2, but you should also look into the other factors. The next slide, I think, is very important actually, because in Denmark we are talking a lot about VDC and BIM and how should we work with it. But now you actually have the opportunity to get these things to work. On the right-hand side, you can see a sketch in the top right corner of a house. Next slide or next picture is the panel layout, and then bottom left is the row house, and to the right it's the same house actually in the weekend. And we started erecting the building the 28th of April. And if anybody of you guys wants to, or girls, wants to come and see this building as it is now, you're very, very much welcome to contact me. But as the slide says, what you see is what you get. So this is so precise, the product is so precise. So now we can start working with the BIM and the VDC, and we can start to integrate processes. And I think that's very great. And if you look at least into our logo, we say more than sustainable, and that's actually one of the factors that we can work with BIM. We take the BIM drawings directly into the production, and so what you draw is also what you get on the production side. And the next step would be to include also business processes, so we could also add in our purchasing system. We might have larger projects than this, of course, so we can add in the purchase system, the Sigma calculation, and so on. So things are becoming a little bit more clever. And then, of course, not to forget the design opportunities. You can have some normal buildings, you can have multifamily houses, you can have higher buildings, you can also have single-family houses, but you can also make some great buildings with different opportunities. You can move loads sidewards, upwards, because it's a light and it's very stiff material. And I will actually show you a little bit or a few pictures of what I think is a very interesting building. It's a new library in Barcelona, and it's actually erected at the moment. Some of the pictures I will show you were taken in March, just before the Corona closed down. And not much has happened since, but now they have started up at the construction site again. Look at this picture, for instance. Look at the way it's working, and the view through it, and how you move around with the loads. I think it's very impressive. And here you can also see the combination of materials, as Michael discussed or talked about in the opening. Here you use steel. You will also have concrete, and of course you will have glulam and CLT. So it's all combined, and I think it's very interesting. Unfortunately, I got some latest pictures yesterday, which I wasn't able to put into the presentation. But if anybody wants to see more of this building and be challenged by it, you're most welcome to contact me, of course. I look forward to see this building when it's done. But here you can actually see, I think CLT is quite a simple product, but the way it's used here is so challenging that you will get a great architecture. So the conclusion of the idea and why, seen in my perspective, is of course the sustainability factors, but it's also the BIM-BDC and the process factors, so we can start working as a professional industry in the building industry, and then it's also the architectural freedom. So that's a conclusion on that. When we look into the processes and the decisions of how we're working, of course, early involvement, like any other project, is important here. And yes, we will be able to go into a dialogue from this industry with any kind of architect, building owner, engineer, in order to optimize the projects. I will come back to that. As I said here on the slide, the CLT is new in Denmark, but bear in mind, there's a lot of things happening outside in the world. So a lot of knowledge is there, and we should use it. And of course, by taking the knowledge into the early stage of a project, the sketch project, we will also be able to have the benefit of it, like in all other projects, like when you work with concrete or any other product. But we should really do that, and the knowledge exists, and that is very important, I think. This is a few pictures from a international wood construction conference I participated in December in Innsbruck. 2,500 people were there nerding about wood, and this is a yearly conference. So many things are happening, and so much knowledge is there. So we should just get it in, and I think that's very important. Then you should use the sparring through the design process. So this picture is, I don't think I offend anybody, because it's a matter of sharing knowledge, and everybody are interested in that. This is a meeting we had at Sweco, where we were designing 62 row houses. And the guy to the right, he's a structural engineer from Austria. He has worked with CLT for a number of years, more than 10, has his own agency, only working with CLT. Half of his time is only working with KLH. he's an expert. He can make the calculations. He can just take them out of his sleeve, and of course people are listening carefully to that. So we should exchange facts from other projects regarding design, as I said on the slide, planning, structural engineering, acoustics, fire, and also the education on the installation, and I will come back to that. So the do's and don'ts, let's work together with that, or work together with the industry. And then the last slide on this part, I must say the CLT guys, they know their business, like the concrete guys knows their business. But these, I'm impressed. I've also worked with concrete and other products, but they know how to load a truck. They know how to make the order of assembly. They know how to optimize the production of CLT. So everything is just in order. So you will be guided through the process. The building in the middle, or the small layout in the middle here, you can see the layout of the small house we built in April. And you can probably not see the numbers on each of the elements, but that's actually the assembly order. So we will discuss a little bit, okay, how will we assemble this, and then it will be ordered, and then it will be loaded on the truck. So the first of the truck is the first element to install, which is of course clever, but also quite intelligent. So it's easy to work with, and it's a business which knows exactly what they're doing. So the conclusion, I think, on the processes and the decision here is you have the knowledge, you should use it. You have the opportunity of early involvement, and you should take the large savings you have making the optimal design. And then actually planning is quite easy. And I will actually come back to that on some of the next slides. But this product is so precise. The tolerance is 1 to 2 millimeters, so you can actually carry on with your work immediately. So when we look after the design process, we're going into the production. And then, of course, you have taken a lot of decisions before you get to this stage. On the top right corners, you see some different examples of construction systems, whether you will have a single layer or you will have double layers. Where will you have the acoustics made, or the effort made regarding acoustics? Where will you have your effort made regarding fire, and so on? You will talk about surface qualities. Normally you have different surface qualities. We have 3 surface qualities. You will of course place the door, windows, and so on. And also you can see some pictures here regarding installations, pre-made installations. Some of them are hidden because if you have a visual surface, you don't like to see the cables, of course. And if you don't have a visual surface, but you will have a gyprock outside, then you might be able to have a visual installation. You will also talk about your cutouts, because when you have a window, you have a cutout piece. You can either get it with you to the site. You can also use it for instance, window frames to mount the windows in, and so on. So that is some of the discussions we are making. And you will find normally an ETA standard. There are a number of ETA standards. KLH has made their own ETA standard, so it's CE marked against this ETA standard. So it's very well documented. We also have EPDs, so it's easy to get the knowledge. And I must say, and that's probably because it's in Austria or down there, German related. They are very, very good at making the documentation for the products. So you also find configurators on the home pages, so you are able to mix around with your fire, with your acoustics, and with your structural design, and see how will you make the best structure. And of course, we will, or the industry will guide you. There's just a few pictures of the production, which is actually very interesting to see. It's very different towards a concrete element industry, but the product, what you get out of in the end, is more or less actually the same. It's of course a lighter material and so on. But anyway, the last photo here, I think that's quite important. This is a machine which take a photo of each and every panel going into the CLT elements. Here you see the number of nuts, the size of the nuts, whether you have a rough surface and so on, and it's all sorted, so you know exactly what quality is going to which element. So we know in every panel here. That's very interesting, but it's a very interesting thing to see. On the right-hand side, you see a finalized panel where where the CNC is working, and you're cutting out to doors and windows and installations and so on. It's all done automatically. It's all done by Revit, talking directly to this this machine. Then we are delivering on site, of course. You have different kind of load systems on from a truck. We have discussed, or you have discussed with your business partners, whether you want the side covers or full cover or no cover, or whether you're working with a temporary cover of the building. What kind of crane? Do you want to wax the timber ends, or don't you do that? Do you want to cover the visual quality? That's a black fabric you can see in the top picture. That is some cover fabric to the visual quality. We will talk about teams, who will do what, number of teams, what kind of protection system, and scaffold, lifts, and so on. And then, of course, when we mount, we start to mount preliminary, so we will just attach a few screws, but immediately after, we attach all the screws, and we will also make the quality check right away and on the go. And here's just it's actually some sites from the UK we are looking at here, and as you can see, they are not using a lot of cover, full site cover. That's not their concept. They are ensuring that the water is not piling up on the elements, but is quite resistant towards that. And then, of course, after the installation of the elements, you make as I said, the final fastening. You check the surfaces. You put on the tape on the on where you assemble the elements. Normally, you don't work with any plastic membrane here. Because of CLT is tight itself, airtight itself. So, but you will put on tape on the joints. And then you will immediately after, and in my experience, you could work on the frames around the windows just right away after your assembly, so you can start mounting the windows immediately. You will work of course, on the facade, on the insulation, and as normal, and the facade system. You can even put bricks outside, and on the roof construction. And as I said here, please do not hesitate to make a thorough plan and continue the work immediately, because you have the chance to it. I mean, this product is so precise, so you are able now to work immediately after with the next steps. I've experienced in our other businesses and other projects that normally you put in a little bit of time lag because you're never fully sure what's happening and so on. Here you are actually very sure what's happening. So now you have the opportunity to work immediately. And of course, keep the building dry. I mean, you have a dry product coming in to your site, keep it dry. And there are, as I mentioned earlier, different possibilities to do that. And then finally, in the end of the day, remove the cover and correct any damages which has happened. But I must say it's not much. But of course, things can happen. So in the end of the day, execution and production, you have made your construction strategy, maybe together with your business partner, in some cases, for hopefully us, but in other cases, other partners. You have no tolerances here, or very low tolerances, so make the quick assembly and keep the building dry and make your final quality control, and you are on the run. So in total, just recapping. First, CO2, sustainability, BIM, VDC, and the lean processes also in the design. That is the idea and why, and the architectural freedom, don't forget that. Next, the processes and decisions. We have the knowledge all over the world. We are taking some of it to Denmark now, and use it, make the early involvement in the design process. We are very much, and everybody around the table are very much keen on going into also being part of the design phases, and let's make the planning. And finally, on the execution and production, you follow your strategy, be aggressive in your plans, and keep the building dry, and make a thorough and good quality control. And my last slide is just a little bit of appetizer to see some of the nice buildings which are created around the world, and hopefully it's also giving you a little bit of appetite, Michael. So maybe I should invite you into the screen again, and if you have any questions.
I do have questions, Per. Thank you for your presentation. We actually got one from the audience, and the first one is, who's the architect of the Barcelona library? Do you remember that? Or we can send
yes, I have the name, but please contact me afterwards so I can give the details, or I can write it there. I can actually find it during the other presentations. I can't remember the name, but yes, I have it.
Then I have some questions regarding, do you do turnkey projects? I mean, where you deliver both the materials and the people for mounting it?
Yeah, our setup is that we don't want to right now employ blue collar workers, but we have found some very good business partners, large contractors and smaller contractors, depending on the size of the project. And so we can easily find people who we will educate and use. So yes, we can also make the turnkey projects. And of course, if it's a fully turnkey project, we would find the right contractor to work with us.
I also want to understand whether you only deliver the CLT as an element compared more or less like a concrete element, where you said you mount the windows on site and the insulation and the covering. Do you also deliver finished elements where with the inside surface insulation, windows mounted, and the outside raincoat as a
that's not the first time I've had that question, and I would say, depending again on the project, normally we would come with the elements as you saw on the truck. Normally we would use A113 as our split of design borderlines, but depending on the project, of course, we can also add other prefabrication, because I think that's very interesting here. Now we are working a lot with BIM and VDC, and so next step would also be to be more clever on the prefabrication, and that's not difficult. And it's also making, coming back to my last point regarding a dry building, it's also making that a little bit easier. And also because you have so small tolerances here, so you can actually pre-mount the windows, pre-mount the doors, so you will still have a straight line of windows and so on. So I would say, yes, I would very much like to get into the discussion regarding prefabrication. I think it's a great topic to work with, and maybe even modularization could also be an issue here.
Yeah, and then I mean, CLT is quite interesting, and we're actually making books on it right now, and I'll tell you later about that. And especially the static possibilities, as you show at the library in Barcelona. Then there are areas where you just can do things with CLT that you can't even do in concrete. But does it make sense to make a one-floor, one-family house? I mean, you're competing against somebody delivering panels with outside and inside covering, finished, painted, and everything. Does it make sense in one-family houses?
We have a lot of requests regarding one-family houses, I would say, and we are also going to build some. And as you saw, the small house we just saw on the pictures, that is also because people want to see the CLT. So it's all visual quality inside. Actually, we are not going to, well, we will of course have cover in the bathrooms, but that's all. In all rooms, all roof, all ceilings will be visual CLT. And there's also actually some pioneers among single families who would like to live in a wooden solid house like this. So, and then you can say, okay, in the economy-wise, I think it might be the same as a normal house, but you will get it much quicker. You will have a more smooth construction period, and also what you see is what you get in the planning phase. So it's a matter of how much would you like of self-production with your people, and how much would you actually like to prefab and use also the VDC, BIM, the IT tools. I think at the end of the day, it's a matter of taste. Sometimes we also combine wall elements with roof cassettes, which also can make sense. Yeah. And of course, as you also have mentioned earlier, the combination of concrete and CLT is also a possibility, but that's more like in the high rises. But some of the single family houses we're working with, they want a concrete floor and a wooden house, so they have the combination, which is also nice.
So there are several questions from the floors. You don't see me, you hear me from the sideline. So one of the questions is, how often do the architects put a gypsum plate or paint on the inner walls? The wood itself is nice to look at for most purposes.
I can refer to the project where you saw the picture where we designed some row houses, and in that project, it's a 2 and 3 level row houses. And in that project, the staircase will be visual CLT, and the end walls towards the garden will be visual CLT, and the rest will be covered by gyprock and be white painted. And so it might not be either and or. It might be a combination. And I think actually that's also some of the benefits. I've seen projects where you have the ceiling with visual CLT and the rest is painted. I mean, it's a matter of taste, and so you have both ends, and you choose yourself, because you choose a visual quality for one wall. You don't have to have them all in visual quality. Then you still divide, and you will have only to pay, of course, for the visual quality where you get it.
We also have a question about products where you have a damp membrane on the back side of the elements. Do you never do that? I can just add in that we have seen some reports on 3-layer CLT that might not be totally airtight, but we know that the 5 layers are, and there you can challenge. But what do you deliver with it or without the vapor membrane?
Again, it's a matter of what your strategy is. I have got a thorough. I have challenged that at KLH. I got a report of 20 pages regarding air tightness. I haven't studied it fully yet, so I cannot give you the exact answer. I will look into it, and I have also heard the fact that 3 layers are not fully tight. When I'm addressing that at KLH, they are saying no, it is tight. So here we have to also look into what are the Danish terms, and how should we work with that. So of course we will use the technical information and use it thoroughly in the way we are constructing the buildings. I haven't the correct answer for that right now, so I will not answer the question right away, because I have to study the report. I just got it before the weekend. Yeah,
and our concern is actually mostly the joints, and if you're in a 5-layer, we are not that concerned about the air tightness, but the joints are the challenge, and where the errors can occur. We have a question whether you can do curved elements.
Sorry, one more time.
If you can do curved elements.
No, curved elements are normally made of small elements with the right angles, so you will make them curved, but still with so you cannot make them like a glue lamp beam. That's not where we are at the moment. No.
And then there's a question: isn't it too much use of wood if you only are making a single family house using an element that has a lot of load capability for low rise? It's an interesting question because we get it often and we haven't the right answer to it, because is it a good idea to store a lot of carbon? Because that's one challenge we got.
Yeah.
Another thing is, do we have resources enough? At the moment, I can say that we only harvest half of the growth in the wood. So we can actually store as much wood carbon as we like, but on the long term, I think the discussion would actually come up.
Can I just add a comment there? And I think you give me or nod and you're happy with that. We also, when you're working with CLT, you're using a larger proportion of the raw tree than you are on the construction wood.
50%. Yeah.
So in that sense, you have actually more raw material available when you're working with CLT than other. So again, I think it's a matter of your taste and strategy and what you want.
And then the last question we can manage is that how are the acoustics on the hard surfaces of the CLT elements? And if you don't want to answer, I can answer. So
no, but you can answer. I mean, it's also different between if you make a kindergarten, you're making effort to avoid these hard surfaces and so on, and adding on material. So it's also a matter of where are the limits and so on. What would you say?
I think the experience, I mean, I was presenting a flat in Lisbjerg Bakke. We were 9 people eagerly discussing, and suddenly everybody looked at each other and said, well, if this was an empty concrete room, it would be impossible to understand what's been said. So actually the acoustics in the room is not that big a challenge unless you are more exposed use like kindergartens and so on. The challenge is actually the flank transmission between walls and floors and through the construction. That's a challenge for all wooden construction, and that's an area of high focus. So,
and where you also add in layers in order to avoid.
Yeah. So we are out of time. We can take it up. You can ask more questions. We can bring it up in the end. I will now give the floor to Cosima.
Thank you very much, and thank you very much, Per. And now, asking Frederik Spanning, you are with Cree Denmark, a partner of Vorarlberg company Cree, specifically known for its life cycle tower. You also have some projects in the pipeline in Denmark already, and it's quite natural that you will focus on modular design and its advantages. Please do keep your questions coming. We won't be able to answer them all in course of the webinar, but we'll collect them and definitely also forward them to the speakers and then get back to you after this. But now for the next 20 odd minutes or so, Frederik, the floor is yours. Thank you.
Thank you, Cosima. Thank you, Michael. And thank you, Advantage Austria, for the opportunity to speak here today. My topic today is modular design and its advantages. And I'll be starting with putting this into perspective to look at the bigger picture, talking about the big why. Also moving on to the potential of modular design, and then just taking to a look at our components and the advantages that we see in those, and finishing off with some examples of real life projects. Now, modular design, if you look at that title, you could get the idea that this is only a discussion for designers, but actually modular design is a tool for industrialization. And if I could get this to move on a little bit, modular design is a tool for industrial construction, and as such, it is a very important topic for the whole value chain, not just the designers. I'm not an architect, but I'm very preoccupied with the concept of modular design as how that can create value for us. If we know that if we structure the way that we deal with buildings, we get the functions out of the buildings that we are looking for, and we are creating value at the same time. So let's look a little more closer into that. Stanford Engineering have done research on this, and they produced this slide. So they're telling us that industrialized construction creates value, and what we're looking for, what we've been talking about for a long time now, is the more sustainable buildings, saving costs, having faster production. And of course, these things, they don't come on their own, but if we structure the way that we go about our processes, go about our buildings, certainly with more prefabrication, the increased use of ICT, and use some of the things that we see in the structural markers there on the slide, horizontal and vertical integration, then we actually get the value proposition of industrialized construction. McKinsey, the consultants, they follow up on that, and they've done research on this as well. So why is this important at all? And if you look at this, the bigger picture from a global perspective, McKinsey, they've analyzed the sector, the building sector, and as you've probably heard many times, the situation in the sector is stagnant. The productivity is low and hasn't moved, and they've looked in how can we jumpstart this. Why do that? Well, basically because it has a huge economic effect. The productivity for construction has been behind other trades and other sectors for decades, and it seems that now there is a new opportunity with new tools. There is an opportunity, and there's also a necessity. A necessity, why is that? Well, certainly in the Western world, we're seeing labor costs are high, and labor shortage is what we're predicting. So it is important from a global perspective, and it's also important in our part of the world where we might say, well, we're doing good in this aspect. We are productive already. They're saying that if you follow these concepts of modular construction and bring projects into more of a product rather than the processes of products, or rather the processes of projects, then there is a huge potential in time savings, 20 to 50%, and I think that's a goal worth going for. But aren't we modular in this part of the world? We've certainly have had a development in this part of the world, but it's not quite enough to get the full benefit of all of this. We need to do a lot of optimizing. We've been talking about materials, and we've been hearing Peer talk about materials. So yes, that's of course an important part of it. But mastering the design to support modularization is of course very important. Our technology needs to support it, and the whole outset has to take logistics into consideration, and of course assembly being something that we have to take care of right from the outset. The outset in this way of working has to be early. We cannot wait till we've decided on perhaps the aesthetics of the building. We have to start very early, and as we've heard previously, BIM gives us some opportunities, but we have to have a real determination to have this discussion at the earliest possible time, and today with very well defined components, it is possible to have a real discussion at the very early stage about how to become modular, how to improve this productivity, and of course the goal for a lot of us is to save costs when doing this. So early discussions, according to the McKinsey research, will bring us into a situation where we get a kind of a sweet spot between quality, time, and costs, and we can bring these meandering processes that we have in construction into a true discussion about the actual product, which is what the client brings away from it all. But we are modular. Surely we must be modular in Denmark. We think we invented the prefabricated concrete system. Well, maybe we did. And of course we are modular. I mean, we've been using bricks for hundreds of years, and there are lots of modular components in our buildings. But even the building on the left has some sort of modularity to it. And surely you would say the building on the right is the result of an industrial process. But we're not quite there yet. We have gone, certainly in the 50s and 60s in Denmark, through a great wave of industrialization, but we haven't moved productivity, and we haven't really moved time. We're not really faster than the building we saw on the slide. So what is it we have to do? What is the next step in this? Well, if we really want to be industrial, we need to look at the components, and of course the materials. We could be inspired by this sector. In this sector, they reuse knowledge. They have very high precision. They have digitalized processes, automatic processes to a great extent, and of course we're lucky now. We've been talking about wood. We've been using wood for a long time, but actually it seems to have come together over the last years that wood seems to be the perfect material for construction for a lot of reasons. We've already heard some of them today, and why is that? Well, basically it's because it supports the idea of modular. It can be made to very high precision. It supports the idea of industrial, and it's possible for us to make this transition today, and even maintaining all the requirements, all the regulations that we have. In this case, in Cree we've used it to use for a systemized approach in the LCT system, but we also use other materials mainly for the reason of regulation, but also because we want to use each material where it's best. So to do this, to get the efficiency, to get the productivity and the low time, high speed on-site, we want to move away from the on-site processes. We can't control them, and we want to move into controlled environments where the environment is good, the work and health aspects are good, and basically bring prefabrication as far as we possibly can. The more accurate we can be, the less time we save on site, the more we can bring up productivity, the faster we can do it. Here, slabs ready to be shipped in. The more functions we can put into components. In this situation, or in this picture, we have a facade element with multi-functions. It has load-bearing capacities, it has a window, the insulation, and it also has finished surfaces. And not least, it has an ability to be shipped and assembled very quickly. logistics is a huge part of it. Of course, we need to have logistics as a kind of a driver for the design, and to think in the logistics right from the start. So what we want to do is we want to move away from the sort of erratic, non-controllable processes on site. We want to be able to assemble very quickly. In these examples, you have industrial components that are very simple. They are repeatable. You basically have the same type of connecting in all buildings all the time. So in that way, there are no surprises. The joints are visible. They're not interlocked and cast together in a way you can't get them apart. So you can also disassemble, but it's repeatable. It's simple. You don't have to reinvent it every time. So the concept of moving construction into assembly is a very important part of it. And of course, all of these aspects need to be put into play and be aligned for a very quick assembly. A lot of you have seen this before, but it's still a very good example, I think, of how to put together a building of 8 floors in 8 days. Now, obviously, a lot of thought has gone into this in order for us to do this, but it still says something about how to be modular, how to be industrial, using the logistics as a design driver. And you end up with this room. It's a dry room. It's a superstructure that's airtight, weathertight. You can make a blower door test on this, and you're ready to work the next day on the next layers that have to be put in, the next surfaces that have to be put into the building. And what drives this? Well, the wood gives us the opportunity to have a very high precision. We have such a high precision that we draw the tolerance and we build with the tolerance. It lowers our risks and it increases our value. Being digital is a huge part of this. And maybe this is not the sexiest of slides, I admit that, but there's actually a small film on this, and I might just urge you to go into our technical partners LinkedIn profile, HD Lab. They helped us by making a parametric design where we can use the specific components. So some of the components you see in this slide, they actually put together and as a tool to make the design at the very first meeting, almost the very early days with clients, with architects, with the design engineers, make an easy to use sort of interface on how the components, the actual real life components, are used at the very outset of a project. So have a look at HD Lab's LinkedIn page and see how the modulo that they quickly hacked with the simple software, how that can be used to generate buildings and bring home this message of modularizing the construction home to the partners in the project, and that way get this integration vertically and horizontally that we're looking for. So why does it all have to be square, you say, when you build modular or industrialized? Well, it doesn't really. All we're looking for is repeatability, and for modules that can be built and transported. In this case, you can see various footprints, all built with the same solutions for same detailing, the same connection details, and the same industrial processes. I'll just show you a few examples of how we've used this in real life projects and some visualizations as well. This is from a project that's started in Berlin, 30,000 square meters in the SXB building, which is it's again a project that's used these principles. The Ionia College, Singapore, another huge project where wood has been used, but also the concept of the modular design and the industrialization. The main building, the office building of the that has given the name to the LCT system. You know, some of you have seen this before in Austria. This building is 10,000 square meters, and the superstructure was put together in 6 weeks, airtight, weathertight, ready for the next parts of the construction. This is a project that we've applied building permit for, and we've done that a long time ago. Now it actually seems to be moving on. In this case, it's been given this look, and this design could have a different facade to it, perhaps with visible columns behind it. This is another one where we've applied for building permit, and also this one is we've been told is coming up in Denmark. 30,000 square meters of office space in Bremen in Germany. Just as a reminder of what it is we're trying to do here, 5 days of assembly for the stairwell core, but only 10 days for the rest of the building, and you get a closed, airtight building. And yes, that's it for me.
Yes, we got some questions from the audience. How do you cope with fire regulations if you go higher? It says higher than 3 floors, but I think the question might be in relation to 4 floors, because I don't see that many challenges in 3 floors.
No, I agree. Our project in Østerbrogade is 6 floors, and we have a 120-minute fire rating on our slabs, which is of course a very big part of it. So so when we put together the fire strategy report, then we have 120 minutes on some of the main components in the building. But apart from that, buildings of course needs to be designed for good escape routes, and maybe the spaces need to be sectioned off, so so they're not as large. So there is a limit to how much volume you can have in one floor and so on. But really, it's a matter of taking each part of the building and looking at the risks that of course are there with fire, and then dealing with them. It could be passive systems, it could be active systems, but the main part of it is using concrete with wood to create a slab that is certified to 120 minutes. So this is where we use the qualities of concrete, and also using glulam, which is the wood that we use for the majority. It has a very controlled way of burning, and we can control that, and we can prove that.
Yeah, so the Østerbrogade project, the challenge is not the fire issues, but other issues, I guess.
Yeah, we've been working a long time, as you know, with the Østerbrogade project, and it's mainly planning issues that have been the problem with that. It's not to say that authorities in Denmark, they don't have questions about fire, but we've been helped greatly by this new opportunity where the certified fire engineers they take over from the authorities, and that way we can have a very sort of very specific discussion about how to deal with fire in the project. There are many opportunities of complying to the building code when it comes to fire. Because a surface is of wood and can burn, doesn't necessarily mean that you can't comply with the building code. The building code itself doesn't say that doesn't stipulate anything about materials. It comes as part of the solution.
I have some other questions. Can you take the building apart and then move it to another place and re-erect it? Even a question saying a school becomes smaller, less children. Can you take part of it and erect it another place?
Yes, we've made we've experimented with this, and we've actually taken parts of a building down and made a disassembly manual, which is probably not something you see every day in construction, but we have a manual for how to lift and where to cut and where to move the various elements, so you can take them apart and move them. So yes, that is possible. As a general thing, our system is designed for disassembly, but of course there will be choices along the way in projects where, if this is a big value for the designers and the clients, that needs to be stressed as well, so you don't end up putting in something that actually cannot be disassembled. But as main elements and in general, yes, it's certainly possible.
I also have questions whether you have production facilities with the concrete part in Denmark, so you can avoid long distance transportation since it's become a little heavier.
No, we don't have production in Denmark. We have right now we have production facilities in Bremen in Germany, and we have calculated the CO2 emissions for transporting it, and compared to transporting it from Aalborg, or the northern part of Denmark, there is a very little difference in that. And when using as much wood as we do and substituting as much concrete as we do, by far and away the most CO2 is saved in the superstructure alone, in the load-bearing structure, and it is a very small percentage that we emit in transporting it, even from Bremen. But if we get big enough projects, we can certainly set up production in Denmark, and we have partners who are willing to and interested in doing that.
I also have questions about, now you talk about strength, sudden accidental high loads. How do the system cope with that?
Well, I mean, as with everybody else, we have to prove that our building can withstand removing key elements and can withstand progressive collapse, and we do that. Wood has a good ability, a good sort of strength versus weight ratio, so it's lighter, but it also has good tensile strength, and that gives us an opportunity to prove that the buildings, they will hang. They will, of course, if you take out a key element, there will be a deflection, of course, but the inherent strength of the combination of the materials will keep the structure together.
Then I have a question. Many of the projects you've shown are office buildings and such. Can you, if you do social housing, there's a very tight economical frame around it. Can you build with this system within that economical frame of social housing?
Yes, I'm sure we can. As with all projects, there are a lot of decisions that has an effect on the cost, and if it is a factor from the outset of the project that this is the defined economy of that project, and there's full integration, and everybody's willing to work with modularization and industrialization and taking the decisions that enable that, then that will be possible as well. Of course, there are, when it comes to housing, there are of course very important decisions when we talk about the width of the module or the width of the rooms, and that can be solved, but it's important that everybody embraces that situation and let it be part of the early discussions of the project.
There's also a question, and it looks from your pictures as there's a lot of manual labor in making the concrete part of the element. Does that affect the tolerances?
No, we have the concrete that we produce in the slabs we do externally, so that is a prefabricated process, and we have we produce to a very high precision. When we put up our slabs, there is 10 millimeters between them, and there is 10 millimeters between them, and that way we can produce a whole floor of 1,000 square meters, and you still end up with 10 millimeters between each slab. So there's very little concrete work on site for the main structure, but of course you still have the stairwell core, which is made in concrete elements on site. So that's the business as usual, you could say.
Talking about the core, there's also a question: have you tried to make the core in CLT instead of concrete?
Yeah, not in Denmark, but there are projects where they have made the core in CLT. We would love to make the core in CLT, by all means, but the way we have viewed this now in Denmark is that we want to take some steps here, and to have a stairwell core where we can make a better point of the fire safety. Then we've decided to do that for now. We are very dependent upon the strength of the core. All our horizontal forces have to be put into the membrane of the floor and then delivered in the core. So for taller buildings, there is a risk that CLT will not be stiff enough. So therefore, we are looking for concrete right now. But if the building isn't that tall, then we can certainly use CLT.
That was the last question. I can add on that we had a previous webinar dealing with the transportation and because we were a group of architects seeing one of your projects, and some were starting discussing, does it make sense to transport all this amount of concrete? And there's made an Austrian PhD that we have made a webinar on, and it's on our homepage. We made it together with Advanced Austria, and it actually shows that you have more truck transportation doing on-site, adding concrete from pumps and so on. There's a lot of more staff, a lot of more handling, and a lot of more truck. So from a LCA point of view, it does make sense actually to do this. But of course, we also have solutions where we don't use concrete at all. That's another issue that we can talk about another day. So thank you very much for your presentation, and I'll give the floor to Cosima.
Yeah. Tusind tak, Mckellen. Tusind tak, Frederik. Thank you for sharing your insights. We're moving on to our next presenter, and I welcome Johannes De Panne from company VHAG, a company that specializes in engineered timber construction with a number of iconic and award-winning buildings all over the world. I remember my days back in London when the nice Crossrail station was inaugurated. So you will be talking about complex wooden buildings. You've also been quite active over the recent weeks, if I'm not mistaken, in Denmark. And yeah, we look forward to your presentation. Welcome, Johannes.
Okay, thank you, Cosima and Michael, for this great opportunity. Yeah, a few words to my background. VHAG do design, manufacture, and installation of customized glulam and CLT projects. We are a family-owned business since 170 years, and we do the projects worldwide. Some of you maybe remember the Paneum in Austria, the so-called House of Bread, or as Cosima said, Norman Foster's Crossrail station, the longest timber building in the UK, or the ice park Eilat, which has the longest span in timber in the whole Middle East. Yeah, we are based in Altheim, a small village somewhere in the middle between Vienna, Salzburg, and Munich, and we have sales offices in London, Stuttgart, and Bilbao. So you can see Denmark is not too far away. In the next 20 minutes, I will present 3 case studies. The first is the Mckellen Distillery in Scotland. The second, the St. George College in UK. And the third, the local project, the Hans Christian Andersen Museum in Odense in Denmark. The first is Mckellen. Some of you maybe know the Mckellen. It's one of the most expensive and most famous whiskies. So sometimes bottles are sold for more than 1 million euros. And so the first precondition, or the most important precondition of a project, was already fulfilled. That means the client has enough cash. So he decided to make a great design. They involved Richard Rogers, means RSHP architects, and Aros engineers. Robertson have been the main contractor, and we were responsible for the timber roof. And as Per and Frederick said already, early engagement is very important, and that was the case in that project. So we were on board at a very early stage and could influence and could help them and make the project a good gain for everybody. You see how a distillery is built up. You naturally have the mesh house, then there are 3 number of still houses in the visitor center. That means 5 areas, and the architect decided to make 5 hills over that 5 areas. In total, a bit more than 200-meter long and 63-meter wide. It's a grid shell structure sitting on a steel roof. You see a section. You see the architect tried to harmonize it a bit, to bring a bit of regularity into it. So he made 4 domes with the same height, and 1 dome is a bit higher, one over the visitor center. Then the design process is very important, especially on complex projects. You have to think that there are the geometry and the architectural requirements on one side, and then all other have to work, let's say, for the architect more or less. So we have to ensure that the total stability works and that the structural strength of the timber structure is enough. But furthermore, we have then the connection design and the building physics. So complex projects are maybe sometimes only complex because of the geometry, or because of the structural system, or because of the building physics. But in this case, all 3 corners have been complex, and therefore I would say it's one of the most complex timber roofs worldwide. And working with celebrity architects like Richard Rogers or Norman Foster is a great honor, it's good fun, but it means also what they want, they get. So there is not really much room for compromise. And in this triangle, or in this circle, we were running for more or less half a year in a very positive way. So if one thing didn't work, we went back and tried to move it. So we like that design process where we are really challenged to fulfill ideas. It was quite clear that at an early stage we have to make that as a parametric design, because you spend a bit more effort at the beginning, but then at the end you have simply easier life if you have some changes. The architect was also quite used in parametric design, so we received an Excel point cloud for the geometry, and then we made our Excel macro. That means we put a lot of parameters to the Excel and transferred it to our structural system, and from that then to our drawing system. And so starting with an Excel sheet, you have then at the end a 3D model, you have the drawings, you have all your lists, and you have already your information for the CNC machinery in the production. The structural system is like that. So on a steel structure, which is maximum roughly 27 meters away, we have a timber grid. If you look from above, from the first view, it's very regular. It's really a 3 by 3 meter grid, but due to the hills, it's getting then very complex. Even with all the parametric design and all the CAD work and the computerization and the digital work, you still want to touch something. And we talked a lot about the connection. how does the point look like when 4 beams are meeting in this complex geometry. And so the architect made some samples in his model shop, and we have made some node in our factory. We lift it up in the air to get a real understanding how it looks then in the project, because it doesn't need to see it whatever from 1 meter distance. But if you have a closer look like that, you realize that it's not only glulam, it is a glulam core with LVL cheeks on both sides. That was an architect's idea. He liked the visual look of the LVL. It's more industrial. And with that cheeks, you create also a channel on the bottom side, which was also an architect's idea and makes sense. So you see here the finished geometry, and you can understand why there have to be so much effort in that connection. It's not only the strengths and the geometry, it's also the building physics or the durability of the beams, and therefore a few different beam build-ups have been used. You see here the regular beam type, where you have the glulam core and the LVL cheeks and different connectors on both sides. Some beams have been outside, completely weathered, because there was not really a roof, there was just a stainless steel mesh, and so the beams are always weathered. And in this case, we applied pressure-treated LVL panels, but with a small gap for ventilation. So the structural element is always dry and lasts forever, and maybe you have to change just the LVL panel every, whatever, 25 or 30 years. Some beams were on the gable, so again we had to apply a pressure-treated panel, including some insulation. And where the glazing facade was meeting the beams, we naturally had to apply or implement the vapor control layer to ensure proper building physics. You see now some pics from the production. Here you see the connections. One advantage of the LVL cheeks was that the connections could be quite, let's say, straightforward, very traditional, no big architectural requirement, because they are anyway hidden from the panels. And once you push the button in the production, suddenly a lot of steel parts and a lot of timber parts are there, and one of the most, or the largest, the biggest challenge was simply the logistic, that you know which element goes to where. That was handled with the barcode system, so our production is really fully barcode guided, and so every element, every single element, and then the finished element, composite element, has a different barcode, and we know which element has to be on which position on the truck, and then of course on site. See also a picture from architect's inspection or client's inspection. And then next slide shows the installation and the production of the roof decks. The roof decks are made of CNC machined timbers and then manually screwed together, and again CNC driven application of OSB and LVL boards. The panels have been, let's say, empty because it was a green roof, so all the insulation was then on top of this structural deck. You see, they look maybe all the same, but they're all slightly different, and that brings the complexity in the project. So yeah, complex thing and the challenge, as said, is the logistic. And if you see, you have 1,800 number of beams, and 750 of them roughly have been had a different geometry. You can imagine that this is a challenge, but yeah, all went well. Same challenge on the roof decks. Most of them have been triangular in order that you can achieve that shape, and again, more than half of them were at a different geometry. So the production was finished, or we had enough, and then we shipped everything on site. So this is a picture of the truck. The transport itself was more or less a walk in the park for us, because it was just 20 or 18 meters. I show you a slide what we are normally doing. So if you look to that, it's a 48-meter transport, or even a 65-meter transport. But as said on that project, it was not a big issue. It was just 20 meters. So the installation starts. We required some temporary props for the domes. Normally you make that maybe with a scaffold tower, but as we are a timber company, we make our timber tower with a hydraulic jack on top to allow support during the installation. And then we lifted the beams and beams and beams. So really after 25 weeks long, 2 gangs, 2 cranes, we installed the beams and then the roof decks. Yeah, for timber construction, it's very important that the high quality product which leaves the factory remains also a high quality product after installation. That means we don't use any belts or slings. We use wherever it is possible kind of lifting points, lifting screws to maintain the quality. See here, clouds are coming, typically Scottish weather. So there was a lot of wind and a lot of rain, naturally because it's in Scotland, but yeah, everything worked well during the installation. Also the roof decks are flying in, and you see they have to fit really perfectly. On every project you discuss a bit the tolerances and how you manage tolerances, but honestly with the CNC machinery nowadays, please forget that. It's not a real issue. It simply has to fit, and it fits. Another view during the installation and check of the moisture content. Interestingly, that project is the driest project that we ever have done because of the still houses. The still house is running 365 days and is permanently heating. That means the timber content goes down to 6 or 7%, which is really very dry for timber. You see how perfectly it fits to the Scottish landscape. And yeah, health and safety is also a big issue. We always pre-install a safety net in our roof lights, and we make also some safety courses, safety trainings, on-site trainings. So that's not an accident, that's just a training, don't worry. And you see how steep the domes is, and with that kind of a top looks fall arrest system, yeah, we had 0 accidents on that side. See also the taping of the joints to ensure a very quick temporary weather protection. And you see how perfectly all the beams and panels are lined up. At the end, somebody else put on a green roof, even with a watering system for the Scottish desert. But it was also interesting, yeah, how this works. And yeah, finally, a few signature shots. Here you see how long the project is, and yeah, on the one side they're pouring the concrete, on the other side they are starting the roof. And it's almost lost in the landscape. It's maybe hard to find for you. You see the rendering and the reality is really the same. At the end now, some signature shots. Glazing facade. A day's view, a night view, and the final view from that project. It's really a cathedral of whiskey. So once you're there in Scotland, I think it's a must to visit it, not only because of the timber, also because of the whiskey. Just try it, and yeah, it's real experience. So let's switch to the next project, which is St. George College in Weybridge from Blenheim Construction, Scott Brownrigg Architects. Also very complex project. You see that's the campus. Sport was always very important. And in the red circle is probably the most ugly building on the whole campus. That's the old sports hall, 1980s yeah, steel shed. So it was time to build something new. And as the building is between 2 levels, the architect idea was to lift it on the one side and push it down on the other side, and that brought the complexity into the roof. So it's a real twisted timber roof. The section looks quite simple, 54 meters on 3 columns, and instead of delivering a 54-meter long beam, we divided it in 2 pieces, as in that point the moment is anyway almost 0. So that looks quite simple. Also, the plan view looks simple because it's all regular, but due to the twisted roof at the end, you can imagine that every element is different from the other one. So here roughly 850 cubic meter of glue lime, 3,000 square meter of CLT, and we have been 11 weeks on site for that project. Some pics from the production. You see, it's very important to pre-install the steel parts in order to have easy life on site, to have only steel-to-steel connections on site. Also here, these are the secondary beams, the purlines. And then you see how big the elements are. 1.6 meter deep, 24 meter long for the main beams. Few pics from the installation. And you see the top edge of the beams is slightly facetted to accommodate the CLT panels. The bottom side is perfectly curved. Great picture where you see all faces, beams, purlines, and cross-laminated timber. You see here the double layer of purlines. It's also architectural. You could do perpendicular purlines and just one layer, but you wanted to have 2 layers and some penetrations through the beams. And yeah, once you walk on the roof, you feel a bit drunk because you have no horizontal surface. Always it's going up and down, but it was a great experience. And final signature shots from that project. They have even a glass floor. That means with LED lighting underneath, so you can switch on your basketball lines or your volleyball lines. Really spectacular sports hall. And the last shot of that project where you see really that complex shape of the timber roof. And that leads me to the last and local project, which is the Hans Christian Andersen Museum in Odense. Our client was the city of Odense, and they got the money from the Maersk Foundation, AP Möller Fonden. They found a celebrity Japanese architect called Kengo Kuma, who came up with a great design. And they had a very great local design team to make that all happen, which was CW Architecture and Vitae Engineers. So it's really in the middle of Odense. There is a small park, or there was a small park, and now there's a lot of concrete, but at the end it's again a park. As you see, so that's the called sunken garden, that's the rendering, that's the goal. And there are a lot of different buildings, all made of timber, with a great view inside and outside. There's a workshop, biograph realm, children's realm, sunken garden, shop, foyer, different buildings, so very complex combination. If you look to that picture, that is the architect's intent. He wanted to combine, let's see, the traditional building type in Odense with the natural random of a tree to create then this structure, which perfectly worked. You see here, again, from digital drawing to reality, this is the children's realm. Left-hand side is the WIHAG model, and right-hand side is reality on site, maybe 1 month ago. Again, the production with pre-installed steel parts. You see a plan on the slide, so even with all that digitalization, you still need hard copies on site and in the factory, especially for quality control. Pre-installed steel parts all good for 30 or 60 minutes fire resistance. And one of the complexities was that on all these round buildings, the center was different. So the facade columns had the center in the middle of the circle, which makes sense, but the beams had their center somewhere else in a concrete tower, which was eccentric. That led to bit complications, as you see in the red circle. So this connection design was quite difficult, but we solved also that one. Another picture of the application of the CLT panel. And you see here how we tape the CLT panel to ensure temporary weather protection, which works quite well for, let's say, 3-4 weeks. And that's a big advantage of the combination of glue and CLT. You have suddenly really closed timber roof, and everything is well protected. Another challenge was that we had to join two very old buildings, so there was an on-site measurement, and then starting from the on-site measurement, we made our drawings, and everything fitted perfectly at the end, so it was correct. So last picture of the job, which was really taken, I think, 3 days ago on site. You see some of the buildings are already wrapped because they're waiting for the glazing or other works. You see the complex CLT panels on the ground, and so we are still on site for the next 3 weeks roughly. In total, we have been then 15 weeks on site, and that was our first project in Denmark. Very exciting, and that obviously makes more appetite for more projects. So if someone of you have something on the table, just contact us. We can help you, but also for the easy projects, not also for the complex ones. Okay, so I hand over to Cosima.
Yeah, thank you, Johannes.
Yeah, very interesting. I can add on if you also have a project I saw in Austria, the baking museum, which is glue lamp lying on the side, and you use the curved glue lamp to make this dough-like structure, which is also very ingenious. I had one question, and that goes: can the construction be exposed to the outside, for example, using superwood? Superwood is a Danish product where they can impregnate spruce throughout, but I'll let you answer. I think there's a lot of challenges in doing that, and I think the complexity of your buildings also show that would not be that applicable. But actually, the facade on the Odense project is actually with exposed wood. Can you elaborate a little?
Yeah, in general, our architects want to express more and more the timber also outside. I mean, traditionally it's just inside or with a big cantilever like on an Alpine chalet. So people know normally since thousands of years that timber should be kept dry. Also Per and Frederick mentioned that several times. But we understand also the architects that you want to express it outside, and therefore there are two solutions. One is to use simply a more durable material like larch, natural material, or you go to more, let's say, new and modern materials. One is Accoya, what we can provide, so acetylated timber, or your Danish superwood, which is also a great material, which enlarges simply the durability. But you still have to think about how you make your details that if water can go in, it also dry out. That's very important. And then it gets critical if you have to combine it with fire with spread of flame. Then you have really troubles. So whether you get more durability or you get spread of flame, it's possible, and these things will be done there. But we prefer, so let's say, the structural element should be kept dry, and if you really have something exposed, it should be worked just as a facade, not as a main structural element. Yeah,
I agree with you. And actually, people are normally very concerned about the lifespan of buildings, and I always say that whenever it's a construction kept dry, it can be 1,000 years, no problem at all. And there's no maintenance on inside constructions. You get a lot of maintenance if you expose it. I haven't got any further questions, and we are a little behind the schedule, so I think we can go over to the next presenter. But I think this presentation actually showed that creativity combined with wood can give you exceptional buildings. So I was very happy to see your presentation, and I know that you have done a lot of other projects, and I think the combination of industrialization and computer is very exposed in these projects, and shows that you can do almost whatever you want. So to the Danish audience, I think grab this chance, because you can make incredible architecture with wooden constructions. So the thesis about wooden constructions is something with exposed wood and looks like a summer house is very turned down when you see projects like this. We have to make people understand that modern architecture in wood can be quite spectacular. So I think this was a very good showcase. Thank you very much. Cosima, the stage is yours.
Yeah, thank you very much. Vielen Dank, Johannes. So yeah, I would like to welcome the next speaker, Bartosz Wojciechkiewicz from company Haslacher. Bartosz, welcome. Your company or company Haslacher is one of Europe's largest and most prominent timber industry companies, supplying all things timber, and you will be speaking about surface treatment. We look forward to your presentation. Bartosz, the floor is yours.
Thank you very much. It's a great pleasure that I can be here as a part of these presentations and this webinar. My name is Bartosz Wojciechkiewicz. I'm representing Haslacher Nordica Timber from Austria, and I was really under big I'm sorry, I forget the word, but I'm really happy that I can see that impressive presentations of my colleagues before, and they said, I think most of the important things I want to say, but I will focus this time on the different way, and I will tell you something about our new technology line, what we installed in our plants, and I will split this presentation on the 3 parts. In the beginning, I will, basing on the few first slides, I will present some information about our company, then I will show you that new technology line, what we installed there, which is really connected to the surface treatment, I guess. And then I will show on the last slide some pictures about that, what we can see there on the production, how we use that on the really nice project in Vienna, and I will show on the end some different examples of the surfaces, what we can do, not only with the system, but also important, I think. So, from wood to wonders is our motto that accompanies us from years to make our products the best, and I think that it leads us to try be a leader in this market. Of course, we know that market change really fast and needs our flexibility and wide horizons, and we want to be able to meet with the client's expectations. I understand that the client's expectations are important because important things are coming on sites, and I mean, we have to fight against some problems what they I mean, clients have on our sites, like problems with dirt, with finishing surfaces, and how to care about that more. So that's our idea how to work with. But yeah, in the beginning, let me to show our company information. So we are a company, family company, founded in 1901 by Haslacher family, and we are a familiar company still. We are located in Saxenburg at Carinthia region. It's the south part of Austria between the mountains. You can see it's close to the Drau River. City is called Saxenburg. There is our headquarters, and also there is our production of blue laminated timber and our sawmill. So we produce there also a lot of things what we produce. And we have few locations in Austria. It's 4 in Preding, Graz, Hermagor, and in Saxenburg as a headquarters, 1 in Slovenia, 2 in Germany, and 1 in Russia. Few numbers of our company will show you what we do. Generally, we do sawn timber, and 760,000 cubic meters. It's it's more understandable if you say that we do 70,000 tracks of that product. So it means that it's really huge amount. Also, we do a 160,000 surface timber, also finger jointed structural timber. So it's 100,010, 380,000 laminated timber, and that's important, I think, in this case, because it's connected to the presentations of our colleagues from which was previous presented some information about that. We do also the soldering boards, pellets, energy, and pallets and different packaging solutions, and of course cross-laminated timber, CLT. And this is something what I want to concentrate actually, because there we installed our new system of treatment. So yeah, if you think about the realizations like you can see on that picture, so it's a cross-laminated timber house. That construction can be protected. So this is what I want to show you in this presentation. So it is our new refinement finishing center, new refinement surface system. So if we want to meet with the client's expectations, which are, as I said before, the problems on the site, I guess, but not only, we have to go further and think about how to help the customers, how to make them free from that problems, like it's, for example, finishing surfaces by painting on sites. And if we talk about the CLT, we can finish it in our factories by the few quality options. We have a non-visual quality option called different industrial quality, industrial visible quality or residential, and excellent quality. About excellent quality, you can find a lot of information on our website. Generally, all the info what I'm showing here is possible to find out on the Haslacher website. So if there is anything what you want, please go there and you can look through and you can find that. That excellent quality is a special cover lamella on the cross-laminated timber, and my colleague 2 years ago, I guess, on similar seminary shows that, so I will not focus on that. But in the next slides, you can see that also, so maybe then I can say something more. And all that surface options can be finished with special sanding and calibrating by the abrasive grain size 80 or 120, depends on the quality and on the order from the customers. And all of them can be also finished by our new surface refinement equipment. And it's surface coating with different products with our new surface refinement equipment, which generally protect our products against the blue stain, UV, yellowing, and grain is also protected. And we can do it in different colors, and of course it depends on the orders and requests from the clients. So using our system, we not think not only about the appearance but also about the situation, and that protection against dirt and yellowing on site leads us to support our customers. So this is why we installed in Stahl in Austria, in our location where we have the CLT production panels, that special robo line. There are 2 CNC controlled robot arms, each with 4 fine atomizer nozzles. They can access up to 7 color cycles and ensure the actual coating on the surface. Subsequent drying is carried out with warm air and pre-dehumidified air. And intermediate sanding system smooths upstanding fibers and prepares the surface for a possible second layer buildup. More and more manufacturers installing that systems, and they are coming from furniture technology, and they are only scaled up to load bearing and to large format components. Before the coating process, special sanding system with several directionless rotating units ensures evenly fine sanding and prepares the element for the subsequent coating. So if we talk about that equipment, we always needs to know what we want to have here, and it's a multi-layer setups with the sanding. It's a fully automatic scanner which recognizes the geometry of plates. It's processed with the digitally from the customer orders data what we already receive, and they don't want to come there and just only they can do it via email. They can send us, and we know everything about it. 2 robotic arms with CNC controlled with 4 spray nozzles. Of course, there is a drying between the subsequent layers. Also, we can polish machine on the polishing machine. We can sand it and make it more smooth. And we use there only the water-based surface treatment, which are protection against the blue stain, fungi, decay, insects. Also, it can be the temporary transport moisture and dirt repellent on the building site. So that is the most important thing, I guess. Also, we can protect end grains and different other assembly problems we can protect here. And all the colors we use, we can do it on request with the which are coming from the palette what we are using. We use it also for the oiled surface finishes, so it's also really possible. So we can use that our product that on all of our products. So we can use it on the glue laminated timber, on the cross laminated timber, and duo trio, which are also our glued solid timber, and on the special components like colleagues shows on the really impressive presentations from glue laminated timber, also on the finger jointed structural timber, and also on the surfaced timber. What are the advantages there? So that system allowed us to make the high resistance to environmental influences. It is applied in the factory, so it's really high quality coating. If you compare it with the possibilities on site, it's much higher, of course, because it's a water-based. We don't have there any heavy metals, no plasticizers. It's really safe without any toxic elements inside. It's under control and really homogeneous. So much better than you can do it on site manually. So it means that also it can be cost effective if you compare it with the application on site still, and wide range of design options here, of course, because you can manage it before and you can manage it through that application. And of course, there is low manipulation effort, so it means minimization the damages there. If we are thinking about that, our goals are that, of course, it depends on the area application. So if we talk about the refinement surface equipment, we need to think that if we think about the visual visible surfaces, then we can protect it on against the UV, and we can use the color response transparent material to cover the surface coating. We can make it with the oiled optics surfaces also. If we think about the transport and assembly protection, then we can protect end grain, we can make it more hydrophobic, we can protect the surface against the dirt and moisture, of course. Chemical preservation is also important. We can protect it against the insects, blue stain and rot. Fire protection also, I know that is a really important issue, and a lot of people are asking about that fire protection. Of course, in different countries, in different codes, and in different conditions coming from customer and from orders, we can do a lot. And if it is coming also with the water-based color, we can do it. But to be honest, we want to do what clients want, so we cannot confirm that, for example, that kind of material did some special kind of preservation. So it's just only up to the order. And of course, we can do the surface ready for painting for the end coats, and yeah, for final coating and for primer absorption on the surface paint. We use different colors. This is an example of our color palette from Remmers. Also, we worked with the Adler products, but we can work with every different products what you need. Just only it needs to be water-based. So we are really flexible here. And right now I will show you some pictures of that system, what you can see there. And you can see here that two robo arms, which are protected to not be so dirty after the work. And on the next pictures, you can see our machine under the work, doing the work. And you can see here the ready panels with open, with cut out holes for the windows with the special CNC works. And we do some things like colleagues said before, that we can do some prefabrication and install there the windows, the doors, and the different things what clients want. Also, we can make it finished with some colors or colorless layer if it is necessary. So it means that we can save time on site. You can see on that picture the special CNC cutouts which we prepared. So as you can see on that, we can also install there the membrane, different membrane, vapor or airtight if it's necessary. And you can do it on the factory, in the factory, and it's really important to do it there, not on site, because you can do it really exact. And you can see it on that picture. This is the really good example from this Vienna building, Hoho. I will show you the picture later, where we installed the windows, and you can see this perfect CNC cutouts for that windows. And then on the right picture, the window after install, and that is the ready wall element you can see here with windows installed and with the CNC cutouts, also with some drillings in the bottom. And here I will stop on the left picture, and on the next pictures I will explain it a little more. As you can see here, it's On the left picture, you can see left and right side of this CLT panel is finished by this excellent lamella. This excellent lamella is 3 layers lamella, so it means that the top lamella is really thin, and it makes it really protected on the, if we are thinking about the gaps on site, and if we are thinking about the moisture content, it will change. So that is our solution for that. That excellent lamella is something what helps us with that problems of gaps, generally of gaps. But its advantage of that is also that we can use there on the surface lamella different products like even oak, birch, or different wooden products like spruce, fir, and pine. Yeah, and as you can see on that picture, you can recognize that there is excellent lamella from left and right side. And on the left side, you can see it without painting. On the right, it is painted with colorless, of course. And you can see that lights shining there. Of course, preparing it in manufacture means that you can check it really well, and the quality control can find everything what is wrong there and repair it before it would be delivered on site. Also, you can see here the membrane, which is also installed there. So you can install everything and deliver it ready panels on site. That should be a movie, and that slide doesn't work, unfortunately, because of the technical issues. So I'm sorry I couldn't change it and then delete it before. So, but if anyone wants it, please write me an email. I will try to find a solution there. And this is that sanding system with several direct funnelless rotating units. And yeah, you can see that sticks which are making the sanding and prepare elements for subsequent coating. Also with this machine we can prepare some special structured surfaces or brushed elements. And all of that we use in the HoHo building, which we delivered some elements of walls and of columns from block glued glue laminated timber and CLT walls with these installed windows there. And this building is located in Vienna, and it is 24 stories, really high building with 84 meters higher. And I think at that moment it was one of the tallest wooden building in the world when we installed it, and it was finished a year ago. We started deliveries in 2016, and we delivered that 365 cubic meters of block glued glue laminated timber and 1,600 cubic meters of cross laminated timber walls with these excellent surfaces and 2 times coated with this water-based. On the right side, you can see that building under construction. On the left side, you can see the example of our wall, where we installed also before the lifting up that glue laminated block glued columns, which are also installed to the panel and then lifted up to the level where it would be installed. And that is a picture from inside. You can see here the combinations of that CLT walls with these block glued columns, installed windows, and also CLT floors and beams from concrete, which were prefabricated. So maybe this is the answer on the Michael questions about that. That we don't have sometimes use that many concrete pumps and deliveries. We can also use the mix with the prefabricated concrete elements, and it also works, as you can see that on that picture. Okay, another solutions what we can do, it's about our possibilities for prefabrication. Also, we can also prefabricate the different surface layers. Like, for example, here you can see the fiberboard which we installed. We glued it on the top of the CLT panel, and yeah, it's for example, this is a wood file Adler, and panel are also delivered on site in this version, and you can see that it means that the situation on site is changed on that way that you don't have to install it on site, so you're saving a time. And yeah, you can see here on that picture how it is under construction. And this is the different special components which we used for cladding panels. It's a example of special solid wood timber on the top, and we use it for the facade system. And it's also painted, unfortunately not on that machine, but on the different system. But we also can use it, and this is the sample how we can find the solutions for the nice surfaces and for the nice realizations of cladding panels or facade system. So that's all from my side. Thank you very much for your attention.
Yeah, we have got some questions, as I expected, as we discussed on telephone and prepared you on. There's a question is that do you paint directly on the CLT, and what about the cracks that will come afterwards? And you did answer that actually on your slides. Perhaps it was not that easy to see, but you do the painting, if it is on the fine surface, on a small 3-layer CLT. You call it Dreisigplatte also, isn't that right? And that prevents the cracking on the surface. Is that understood correct?
You are asking about that excellent quality lamella, yes?
Yeah, yeah.
Yeah, but the cracks are not coming so as it is coming on the standard visual quality. Visual quality we use with the thinner lamella normally. So if you use a standard CLT with, for example, 40 or 30 millimeters lamella, for visual you need to use thinner lamella. So generally we are using 20 millimeters. But if it is excellent lamella, it is also around 20 millimeters lamella, but that lamella is prepared from 3 different cross glued elements, and the top one is really thin. So even if you use the painting, the cracks are not coming there.
So I think that's interesting news for the audience, because some has been fighting with the cracks, but of course it's a more costly element. There's also a question on how do you maintain this coated surface on the long run?
May I ask you for this question again, because I'm not sure that I'm following you.
Yeah. How do you maintain it? I mean, after some years, if it needs repair or be freshened up and so on, how is that done? Is it repainted, or what kind of service do you give it? For instance, if it's a housing and people move out, new tenants move in, they would like a fresh look. So how do you maintain the surface?
I understand. You know, generally the problem is after the delivery, we need to put some color on the trucks also to make the repairs first after the assembling, because always something happens on site. So that is the first step. And after the time when the people are living there or using that, of course, you have to make the refreshing like it is standardly. So it's a standard kind of painting, just only the most exact, I think. So after a few months, or I think not few months, but few that time what is producer of that color required, so you need to do it manually, of course. You cannot take it out back and put it again to the machine.
And then there's also a question, can you make a surface that can actually be used in a bathroom except from the wet area? Can you follow me?
Yes, I'm trying to. I don't think so. We don't have this this kind of service.
Okay. And then there's a question, and what are actually the material you use when you do the UV and the coating that prevents the yellowing? What kind of material is it? As
I showed on the slide, generally we use the Adler and the Remer's products. So even if they are colorless, they have a systems which protect the wooden element by the UV and the yellow also. So, okay. But it's up to the order. If it is necessary, we can use different one.
Okay. And then there's a question whether if you have these exposed surfaces, there's a note on one of the slides that you do fire protection. And how is that done? And I think they are, of course, thinking in a Danish context, because I don't think you can solve it only by a coating. But do you have any comments on that?
Yeah. Of course, you're right. I know that the Remers, they have some product which is fire retardant coat. I think it's named Adolid, probably. I'm not sure because I'm not a specialist on that. And also a different one, Indolin, I guess. I don't remember exactly the name. So, but if you use that according to the technology, what Remers is saying that we should use it and we can do it, then you can make that the flammability of the panels will be influenced probably to the level C. But of course, it depends on the order and on the product that we use. So we cannot take this responsibility for that. The producer is of the material, like the Remers is our responsibility. So yeah, it's a question, I think, more for the technology of the coating.
Okay.
Not on the spraying that. Yeah.
Thank you very much. We have some questions now that are more general, so I think we should go on to the questions. So if you would all like to join in, then we can discuss in between, and I can raise some of the first questions. So we had a question about a general question about water tightness on the envelope. Where lays the guarantee? because it's perhaps another company that is doing the alu surfaces, and if it's a systems solution, it's the guarantee is typical within the system, but the system contractor. But here you have two levels in a way. If you start with the CLT, you put on the tape and so on. How do you deal with this guarantee issue that you have two operators that both have a responsibility for the water tightness?
Should I come with a comment?
You're well welcome.
Thank you. I think it's like any wooden building. You have different systems you combine. I mean, the water tightness is kind of a prerequisite when you're talking about that you have a wet building, but you shouldn't have a wet building. You should have a dry building. So I don't think actually it's a big deal. You shouldn't build in humidity into a building. So you shouldn't continue any work with a wet building. So if you follow your strategy and the rules regarding working with timber and keeping it in a low humidity level, I don't think actually it's a problem. You're dealing with it anyway when you're with wooden frames or anything else. You're dealing with the same problem.
Yeah, and I think also that the responsibility is perhaps divided in a technical sense. It should be divided. I mean, what the CLT provider should deliver is the airtight building, and also a vapor membrane if you have that in the solution. But the water tightness from outside rain lies within the outer surface construction. I mean, you have a windstopper that can take some, but then you have a rain protection facade. So the responsibility for the water tightness, I believe, in the outside system operator. I don't know if you all agree with me.
Maybe I can just add a comment to that, Michael.
Yes.
As a turnkey contractor, we obviously have the responsibility for that. But our facades are built up with with two layers, where the outer layer behind let's say there's an aluminium cladding on the whole building. Behind that we have a outside layer, and that is 10 times more open for vapor than the inner surface. So the vapor barrier that we have on the inside, maybe some type of board material, wooden board of some sort, is vapor tight, and then the rest of the facade is more open. So of course each layer has to do what each layer has to do, but should there be vapor in the facade, it can get out.
Yeah. And when you're talking for, we got a question actually from the last presentation. What is the concrete beam doing in the picture? And that's of course because it's actually the crease system that was shown us on that picture. So you can perhaps enlighten people what is the beam doing?
I expected that somebody will ask about that. So, but it's a standard, as you can see, not only on my presentation, also on the colleague's presentation. There was the mix of the concrete structure and the CLT and glue laminated timber structures, and it comes because of the different things in that project. If I'm right, I remember it was because the structure of the concrete beams makes that construction safe on some fire protection conditions, what we need to cover there. And this is one of the reasons. Of course, they may be different one, but I don't know them. You need to ask the structure engineer of this building to ask how they use that. I guess it's because of some reasons like static calculations.
I'm sure Frederick can fill in, or else I would give it a try.
Yeah, interesting question, Michael. I don't recognize that building as a Cree building, but it's true that it represents the hybrid thought. And when we use our LCT system, we sometimes have a concrete building around the edge. Some would call it a stringer, and that is for static purposes. But it's also actually a response to what it is we're trying to do here. We're trying to use every material to its best possible property. So even though we could exchange the concrete beam with wood, you would probably get a bigger beam if you used wood. And just as an example, it's a good structural element. It has as little size as possible. It's good for fire. It's good for the proof of the stringer and the other statics relevant to the membrane on the floor. So basically, it's a really good example of what it is we're trying to do. We threw all the balls up in the air, and then we said we will try and pick the best version of each of the materials and each of the solutions. And I mean, that would be my answer as to why that is a concrete beam around the edge.
Then I can try my version to explain the audience. The challenge is actually if you build, for instance, 20 stories high, and you have a wall or column, and you place your deck on top of it, and then you continue upwards, then the deck will be compressed because the fibers are horizontal. So what happens when you get to 20 stories, that you get a settlement of the building that equals to totally 10 centimeters if there's pressure, sideways pressures on some of the wooden elements, for instance, the deck. So what you try to solve normally, and I think you also saw it in the Cree building, is to transport the pressure from one column to another without doing it on the deck. So you make a connection through the deck. That's one way of doing it. It can be done by a steel piece of steel tube or some other kind of bearing. You can also see it in Lisbjerg Bakke. You use the steel U profile and put the deck into, and by that way you transport the load from one column to the column beneath through that U profile lying on the side of steel. When the concrete column bearing is used, it's to actually solve three things at one time. It transports the load from column to column, but it also makes a fire division, so you won't have a fire spreading from one floor to another through this part of the building, which is vulnerable. So there are several ways of doing it and solving these issues, and this is just one of them. So,
Mike, can I ask or say a comment?
Yeah, of course.
Yeah, we're also working with these steel inserts, but in general, I was asked about this Spanish architect, and I found out, so I just wanted to give it to you, if that's okay. Yeah. It's called Suma Architectura. I'll spell it in Danish: SUMA ARQUI TECTURA. SumaArchitectura.eu. And then also another comment, I was told before this seminar that we were not going to talk about our companies and brag about our projects, so I didn't. I'm sorry about that, because that was what happened with the rest of the team. So if you want to see a special nice thing in Australia, South Bank Boulevard 55 in Melbourne, there you have added 10 stories on top of a 6-story concrete building in the financial district, and it has a round facade. So look at that. And the last That was South Bank Boulevard 55 in Melbourne. And the last comment I want to brag about is that 1 week from now we will have swan labeled elements as well. So that's we're looking forward to that. We will make some noise about that.
Okay.
And the new factory, we have a paint system like the Hasselbacher.
So that's enough, Per. I actually got a question more. If you can stop bragging, and that was where's the house, that one family house, situated in Jutland?
The house we built?
Yeah.
We have one in Jutland, we have one in Skanderborg, but the one I showed, that was actually in Gilleleje.
Okay.
And we have planned to make some kind of open house there. So if you want to see it, I'm there from time to time. So but it's in Gilleleje, and we have one in Skanderborg as well. If you want to see.
Do you have the addresses on your homepage?
No, I would like to coordinate, I think, when people get there, if that's okay.
Yeah, but you can send them to me. I would like to see them also.
Sure.
Talking about bragging, I will end up bragging for Træinformation. Just mention that I've promised, and I'm ashamed of saying it, a CLT book on how to calculate CLT constructions. And it is actually getting close. We have been challenged by the fact during quality control that we found out that there are different ways of calculating CLT in Sweden and Austria. And actually we found errors in some of the calculation methods, both in Swedish material and in Austrian material. So that has been very challenging for us to actually find out the right way of calculating it. We are so fortunate that we have two quite clever guys on it, also working with the EU standards. So it has given us some extra work actually, and that explains why we are delayed. I'm sorry for that. But at the moment, the plan is to release the CLT construction calculation book in August this year. Yeah, and then we have started up on how to assembly CLT actually in different modes and so on. So we have big ambitions, and we are looking for even more clever people to assist us. So if you know any, I would like to know. So we are 10 people now. 5 years ago we were 5, so we are doing our best. So I think I will give the stage to Cosima. For my part, I will say thank you very much. I'm quite impressed on the high number of attendance to this. So thank you all for attending and for your interest.
Ja, mange tak. Vielen lieben Dank. Thank you very much. Also from us at Advantage Austria to Mikael Koch and Træinformation, to all the speakers, and of course to the audience, also for participating so actively in the webinar, for sending so many questions, both by chat but also by email. We'll get in touch with you. And just if you'd like to stay in touch and receive more information on our future events, on seminars, webinars, and of course on our fact-finding tours to Austria, then please let us know. And in the meantime, stay safe, stay healthy, and stay in touch. Have a good day, everyone.